Welcome to CSDU, where you can learn about the Cambridge Structural Database and how you can search, visualize, and analyze structural data, and how this data and cheminformatics can aid your research and be applied to problems in the discovery and development of new molecules and materials. CSDU is provided by the Cambridge Crystallographic Data Centre, or CCDC for short. The CCDC is a non-profit organisation set up to advance chemistry and crystallography for the public benefit. One of the primary ways we do that is to curate and distribute the Cambridge Structural Database, or CSD for short. Alongside the database, we provide scientific software to enable you to discover more from the data. We conduct cutting-edge collaborative research to help advance structural science, and we do education and outreach activities to help inspire and train the next generation of researchers. Crystallographic databases like the CSD usually include publication details as well as crystallographic, chemical, and experimental information. Importantly, they usually include atomic coordinates too, so we can see the 3D chemical structure and really explore the nature of crystals. Crystallographic databases are special because there is an agreed file format that helps us share and understand structural data, and crystallographers have a long history of data sharing. This means that every published structure can be collated together, and it has enabled curated databases to be established. The structures in these databases are processed and validated, enabling you to learn from the wealth of data they contain. There are a number of different structural databases that exist, and here you can see 4 of them divided by their contents. The CSD contains every organic and metal organic structure, and alongside this database there is the Protein Databank containing macromolecular structures, the Inorganic Crystal Structure Database curated by Fitz-Karlsruhe, and the ICDD containing powder diffraction patterns. Our CSDU modules primarily focus on the CSD, but there are a number of ways you can benefit from the joined-up nature of these databases. For example, ligands in the CSD are linked with ligands in the PDB chemical component dictionary. You can use CSD Crossminer to do pharmacophore searching across both the CSD and the PDB, and PDB deposition pipelines include MOGL, so depositors of macromolecular structures are able to learn from the geometries of small molecule data too. For inorganic data, we have partnered with Fitz-Karlsruhe to establish joint access and deposition services covering all organic, metal organic, and inorganic data. And finally, for powder data, a partnership with the ICDD enables you to explore data derived from the CSD through their PDF4 organics database. Now let's zoom in on the CSD. The CSD was established in 1965 after a vision by J.D. Bednall and Olga Kennard, who thought that the collective use of data would lead to the discovery of new knowledge, and that vision has certainly come to fruition today. Both the structures and the database itself have evolved significantly since then, as has its value to scientists worldwide. Today, the CSD contains over 1.1 million structures and includes data published in associated scientific articles, patents, repositories, thesis publications, or published directly through the database as what we know as a CSD communication. It is a community effort with datasets determined by researchers worldwide, and every single entry is enriched and annotated by experts at the CCDC to aid the discoverability of data and knowledge from the resource. The million structure depicted here was published back in 2019 and can be found in the database by using the reference XOPCAJ. This is what we call a CSD ref code and is a database reference containing 6 to 8 characters. CSD ref codes are used to identify and look up entries in the database. The same substances are assigned the same 6-letter code plus an additional 2 numbers, so polymorphs, new determinations or re-refinements of the same substance, and determinations at different temperatures and pressures go into the same ref code family. Stereoisomers or different solvates, co-crystals, etc. are assigned different ref code families. The CSD contains a mix of organic and metal organic structures with a split between single and multi-component complexes. The organic structures can be used to design new drugs, agrochemicals, pigments, and explosives, with metal organic structures providing information on metal organic frameworks, models for new catalysts, and porous frameworks for gas storage. As well as providing a wealth of information about fundamental chemical bonding and how molecules pack together, the CSD includes experimental data, so you can find things like melting points. As well as experimental information, we have links to other data repositories such as DrugBank, and we have targeted subsets of entries, such as a targeted subset of pesticides. We can delve deeper into the CSD too to see how the chemistry has changed over the decades. Here, we have used our CSD Python API to explore the changing chemical nature of published structures, and you can see the rapid rise of metal organic frameworks, which now account for around 10% of the CSD. We can also delve a bit deeper into some of the experimental details, and we can see that the most commonly reported crystal shape, for example, is a block, although I think penguin shape is still my favourite crystal habit. There really is a wealth of data in the CSD. Each individual structure has its own story to tell, and we hope these modules inspire you to learn more from the collection of data. Today, the CSD is used in academia and industry worldwide, as demonstrated by the special issue in CrystEngComm published in 2020 in celebration of CSD 1 million. The thousands of scientific articles published using the database show how Olga's vision is certainly true today, and I might be biased, but I truly think that thanks to thousands of crystallographers, the structural databases really are the best source of experimental chemistry knowledge. They help us to contextualize insights in structural data and a great starting point for your research to help you get the most out of your own data too. Our CSDU modules follow the same basic format of watch, try, and test. By watching these videos, you will learn what you can do with the software and see a demonstration. In the try section, you'll have the opportunity to use the software by following a self-guided workshop. Finally, in the test section at the end of the module, you can check your knowledge in our online quiz and receive a certificate for your hard work.